All right, on your blank periodic tables, the first thing that we're going to do is label the top as an electron map. So we're not looking at this as a periodic table right now. We're looking at it as a map of where all the electrons are. And then this is the part that already confused a lot of students last time, so follow this. We are going to scoot this box that's here, basically treat it as though it's not there anymore, so we're just Xing it out, and scooting it over so that it can go hang out with its other small friend here. So I'm drawing, I don't have a box here, I'm drawing a box so that it just completes that little block. So the boxes that I just did that with, the box that I just moved, was the box that would normally represent helium. We just moved helium over to scoot it next to hydrogen.
Miss, why isn't it like that in just general?
Because helium, we'll learn more about the periodic table organization in our next unit. Helium is a noble gas, which means that it's stable, has a full valence shell, so it hangs out with the other noble gases. Good question. So after we move helium over, we're going to take one of your markers. So find any color, it doesn't matter which color, just one of your four. And we're going to identify the tallest block on our periodic table. So our tallest block is going to be this one right here. And we're going to outline all of the squares that are in my tallest block. Once you've identified that tall block, we're going to do something like put hash marks on it. You can shade the whole thing in if you want to show that all of the squares that are in that block are going to be part of my yellow block, or whatever color you have yours. After identifying our first box, you're going to take a second color, so a new color that's different than the first, and we're going to outline, just like this, the second tallest block. So that's going to be this block right here. So start here, straight down, straight across, straight up, and then over again. And then same thing, we're going to put hash marks or shade it in however you want to identify that all of these boxes are part of this same block. Next, we're going to identify and outline in a third color our third tallest block. So that's going to be this middle one. I'm going to outline them and then put hash marks across it just like the other two. And then finally, the last thing we're going to do is take a fourth color and we're going to highlight our fourth tallest block. Once you have all of your blocks kind of identified and shaded in, there should be four really distinct rectangles that you have. We're going to go through and label the energy levels in each block. Each block has its own unique energy level labeling. So we've kind of already talked about this on our normal periodic tables, where we talked about how these numbers are associated with the number of rings that we would draw in a Bohr model for each of the elements. What we now know is that Bohr models aren't completely accurate. So this is to represent the quantum mechanics model, which is the more recent model of the atom. So we're starting with the same numbers that we had before on the side, just like that. So the tallest block, the first tallest, we're going to start labeling at number 1. So it's going to go 1, 2, 3, 4, 5, 6, and 7. After labeling the first tallest block, starting at number 1, we're going to move on to the second tallest block. So for me, that's a green one. I don't know what color you did yours, but it's this block right here. The second tallest block, we are going to label starting at number 2. So this is going to be 2, 3, 4, 5, 6, and 7. Next, we're going to label our third tallest block. So that's going to be the one in the middle. We label our third tallest block starting at number 3. So 3, 4, 5, 6. And then if you're good at putting these things together, we're going to label our fourth tallest block, which is this bottom one, starting at number 4. So just 4 and 5. It does really confuse students that they don't all line up. So the first block and the second block, generally people are okay with because we have 1 and then 2's line up and 3's line up and 4's lines up and so on. But this block in the middle tends to throw students off a lot because we go from 4 back down to 3 and then back up to 4. But that is supposed to be that way. It's because the third energy level in the D sublevel has higher energy than the fourth energy level for the S sublevel, but we'll talk about all of that later. So it's making you a little uneasy that your numbers don't match up. That's why we renumbered them and aren't just trusting the ones that are on the side normally. And the other thing I wanted to point out to you is that this is what your periodic table should normally look like. What ends up happening is this small little chunk gets cut. So I just took your periodic table and taped it back together. So this is what you have, where that little section is just put underneath it. But I ended up taping it so that you could actually see what the entire thing would look like this way. The only reason that they cut it and put it at the bottom is so that it's small enough to fit on a single piece of paper and you can still read it and it doesn't have to be tiny. So here, we have this little bridge on the periodic table that I gave you to remind you to come down to this section. If you're looking at your normal periodic table, we are always going to go in numerical order as we read it. So what I mean by that, and this kind of goes along with the third and fourth energy level thing, oftentimes when students try to read this, they try to stay in energy level 3, and then they go down to 3, and then they come back up to 3. But we're not going to do that. We're going to read straight across every single time from energy level 3 here to 3, and then you go down and continue on that way. It's your hand. I'll address it in a second. So how you can remember that is because you're just following the atomic number in order every single time. So if I have number 11 and then number 12, after number 12, I go to number 13, which is here. So you just go in order every time. After number 18, that's all the way at the end, I go to number 19, which is just the next line down. So keep going straight across like this. Same thing for down here. If I have number 55 and then 56, the next box I need to go to is number 57. That's what this little bridge is for, is to remind you that 57 is actually down here. So 57 all the way through 70. And then after 70, we go to 71, which is back up here. And then we continue on. So you're always going in numerical order based on the atomic number like that. All of the numbers that we put on this periodic table or on this electron map, the numbers all represent principal energy levels, or we'll just call them energy levels. After doing the numbers, we're going to go through and add letters to each of our blocks. The letters all represent sublevels. So the energy levels that we have are labeled, N is what we'll use to abbreviate it. They're labeled 1 through 7. So the lowest energy level is number 1, highest energy level is number 7. The sublevels are going to be labeled according to the shape of the orbitals in that sublevel. So it's S, P, D, and F, and we use lowercase letters. The only two that I ever really talk about are S and P. S stands for sphere, and P stands for petal. Again, that's referring to the shape of the orbitals. These letters also go in order of the tallest block to the shortest block. So we're starting with our tallest block every time. My tallest block is this one right here. Mine is yellow. Yours is going to be the same block. It doesn't matter what color it is. That is the S sublevel. So we're going to put an S on that. The second tallest one is over here, mine is green, is going to be the P sublevel. The third tallest one is going to be the one in the middle, is the D sublevel. And the fourth tallest one is the F sublevel. So now that we have each of our energy levels, which are the numbers, and each of our sublevels labeled, we're going to go through and actually put almost like a little coordinate in every single box that will be associated with the specific element that lives in that box. So, for example, if we're starting at energy level 1, box number 1, this is the first box, the way that we're going to label it is 1, S, and then a superscript, or basically an exponent of 1. So I'm in the first energy level, I am in the S sublevel, and I am in box number 1. The box right next to it is still in the first energy level. It is still in the S sublevel, but this is now box number 2. And every single time that we are in a new sublevel or in a new energy level, we're restarting the box numbering. So you're never going to have to count very high. So for example, in this box, it's energy level 2, because it tells me right there. We are still in sublevel S, but this is also box 1. Anything that's in that same column is going to be S1. Anything that's in this column is going to be S2. We're going to go through and end up labeling every single box on here. So I'll do a couple of examples as we go through just so you can get the hang of it. So this box is energy level 3, sublevel D, box number 1. And this is energy level 3, sublevel D, box number 2. And then they keep going, 3, 4, 5, 6, 7, 8, 9. And this last box is going to be 3D10. Anything under this, so this one, the next box below it, would end up being energy level 4, sublevel D, box number 10. This one's energy level 5, sublevel D, box number 10. This one is 6D10. In my P sublevel, it's the same thing. We're using the number for our energy level, so it's 2, sublevel P, box number 1. If I were to pick any random box, even without labeling in front of it, so if I pick this box right here, I am energy level 5, I am sublevel P, and the box number is 1, 2, 3, 4. If I do the same thing in F, 4, then I do sublevel F. This is box number 1. The very last one in F is going to be 4F14. Underneath 4F14 comes 5F14. So every single box has a specific unique coordinate code. I don't know what else to call these. Electron configuration descriptor that goes with it. So all of these that are in the yellow will have S's. It's either going to be box 1 or box 2. All of these in blue are going to have D's. It's going to be D1 through 10. So this is all 1, all 2, all 3, 4, 5, 6, 7, 8, 9, and 10. Sublevel P only goes up to box number 6. So if I do 6P6 or 7P6, all of these are going to end in P6. And then all of my pink ones are going to be F. So take some time and go through and label your periodic table so that we have every single box filled out.